there. Today we are looking at an example for Unit 2, Lesson 4, where we're looking at a graph and trying to interpret it. So in this example, we have graphed Sammy's travels to school. So what his rate of movement is as he's heading to school. So as we look at this scenario, we need to first decide what we think that the x-axis and the y-axis are representing. So in this case, x is representing our time, okay, so how long it takes for him to get to school, and then the y-axis is his rate of travel, or how fast he's going. Okay, so we can see how fast he's moving and then how much time it takes for him to get there. So as Sammy leaves his home, we're starting here at the origin. So the rate in which he's traveling here is a fairly shallow slope, and then it looks like we have a 0 rate of change, and then we have a much higher slope, and then we have a lower slope once again. So at what point on this graph do we think Sammy is waiting for the bus? So when we're waiting for the bus, we are usually staying in one place. The bus might come a little bit early or a little bit late, so we usually try and arrive there a little bit early, and we wait until the bus comes. So what part of this graph represents time that is being spent without traveling? So if we look at number 2, there is no rate of change, meaning that there's no traveling happening, staying in the same spot for this time period. And so we're going to say that number 2 is the segment in which Sammy is waiting for the bus. My next question is, what portion or portions is Sammy probably walking? So there are 2 similar segments of rate of change and one faster rate of change, or a steeper slope. So which segment or segments might represent Sammy walking? So if we think Sammy's waiting for the bus here, it makes sense that he might be riding the bus after he waits there. And so maybe segment 1 represents the rate of travel that he did when he was walking to the bus stop, then he waited at the bus stop, then he rode the bus, and then he had to walk some more to get to his class. So I'm going to say that segment 1 and 4 are probably segments where he was walking. Okay, and then as we talked about that leaves us segment 3 right after he waits for the bus, and that the fastest rate of change is likely the time when he was riding the bus, the segment when he was riding the bus. So looking at this graph, can we predict what would happen if the bus was running late? How might this graph change? So one way it might change is that the time in which Sammy is waiting for the bus might extend because the bus arrives late, which means the place of our bus segment would shift, and then but it would be the same rate of change, and then the walking rate would change, but we want to keep that segment the same length, and he would arrive at school later. So segments 4, 3, and 2 would change if the bus was late. So segment 2 would extend, segment 3 would stay the same rate, but it would be shifted to a later time on our graph, and segment 4, same thing. Although if my bus was late, we might see that number 4 increase if he has to make a mad dash to get to school in time. So maybe segment 4 would increase the rate some, okay? All right, so this is a real-world example of how we might graph information about someone's travel from one place to another. But this changes in rate of change can be used to graph things like productivity in a factory. There are lots of different ways in which this rate of change and graphing and reading graphs of rates of change may help us to analyze data